Hey guys, it's your boy Alex here. Today we're going to be talking about our stats project. Oh, I didn't see you there. So we were inspired for our project by watching the movie Inception, where they talk about the shapes of the maze, shape of a maze, and how long it takes to complete the maze, right? So our question is, does the shape of a maze affect how long it takes to complete it? The two mazes we tested were a circle maze and a square maze. Ugh. We collected our data by administering two very similar mazes, one circle and one square, to 30 lucky individuals. Half of our subjects did the square maze first, and the other half did the circle maze first. Which maze they received first was randomized.
For the plan part, we randomly assigned the order of the mazes to the 30 subjects who were chosen to participate in the experiment. Because we are not randomly sampling, it is not necessary to check the 10% condition.
For our experiment, we're doing a match pairs t-test, where the null hypothesis is that the mean difference is equal to 0, and the alternate hypothesis is that the mean difference is greater than 0.
For our data analysis, and for our state part, if geometrical shapes of mazes have an effect on the time it would take to complete, then we would expect the actual mean difference in completion time to be greater than 0. We therefore want to test these hypotheses. For our null hypothesis, the mean difference is equal to 0. For our alternate hypothesis, the mean difference is greater than 0, where the mean difference is the true mean difference in time taken for completing circular and square mazes. We will use a significance level of 0.05. Looking at the histogram, with no major outliers and very little skewness, the t-procedure should be fairly accurate. Here is a box plot of the difference in maze completion times for the circle minus square times. Here is a histogram for the difference in maze completion times, also circle minus square. As you can see, it is slightly skewed to the right. This image shows our 5-number summary of the minimum value, the quartile 1, medium, quartile 3, and maximum value for the difference in maze completion times, circle minus square. For the dupe part, we will use the following formula, with degrees of freedom of 30 minus 1, which equals 29. Then you plug in your values, and we get a t-value of 3.04 and a p-value of 0.0025.
After completing our match pairs t-test, we got a p-value of 0.0025, and with an alpha level of 0.05, we reject the null hypothesis in favor of the alternate hypothesis, which is essentially that circular mazes take longer to complete.
Reflecting back on the process of finishing the AP Statistics final process, it went fairly well. Some things we could have improved upon was the speed at which we gathered our data. It took a little longer than we hoped it would take, so we ended up having less time to do the rest of the project. A possible improvement is that we could have sampled more than 30 people, so we could have strengthened our results from the statistical experiment. If we were doing this experiment regarding mazes again, we would try another match pairs t-test, but instead of sampling from students at CCA, we would sample from people from an older age group. Also, we could try having 2 samples where one group is from an older age group and another is from people of the same age group that we originally sampled from, and compare the times.